Okay, so we're out in the field. Going to go over real quick here how to check a valve, how to know if it's open, closed, how to adjust it, different things we need to check when we come to the field. So this particular field, we've got two valves banked together. We're feeding zone 1 and zone 2 in this case. The continuous acting air vent is always going to be before the valve. So this basically indicates when I come here, my water is coming into here. It's going to this valve and to this valve simultaneously. Then it goes through, going down. These are hitting my submain. And the color of the pipe is important. So here, we always color code our systems. The blue pipe means this is on the submain side of the field, and it's the feed line. So the blue indicates that we're on the feed side of the drip system. What I need to check here is I need to check my Schrader valve and see what my pressure is after the valve. So got a little pressure gauge here. We're gonna put it on the Schrader valve. I've got right at 13 pounds of pressure. The valve is very quiet. I can't hear much noise, which tells me it's not restricting very much. One way I can quickly check that is I can pop this little spaghetti tube off, and if water exits from the top of this bonnet, that tells me it was restricting. So let's pop this off and see what happens. Okay, so we've got water on the top of that bonnet. That valve is gonna open up even further. And so that tells me that valve was trying to close, and it was restricting some water, even though I couldn't really hear much of it going through there. If I close this valve here, let's try this. I think this will make a lot of noise in a hurry, because what happens is as I close this valve, the pressure on this side increases, which causes this valve to restrict harder, and this valve is going to get really noisy. Okay, so here now we can hear this valve closing. Now this pressure is coming up on this side of the valve, and you're going to see some water weeping out this vent as it starts to close, and pretty soon this valve here will start to make more noise. Again, if I check this pressure, I'm at about 30 pounds of pressure right now, 28. So that valve pressure came up significantly when I closed this valve. So now the regulator is starting to regulate, and the valve pressure is down around 15, 14. I don't have the design with me. I don't remember exactly where this one should be. But if a valve is regulating, this is the noise we're going to hear, and that tells us that valve is doing its job. It's regulating, it's maintaining the right amount of pressure and protecting that drip line downstream. So I'm going to go ahead and open this valve back up. When I do that, this valve is going to quiet down because it's not doing near as much work on restricting things. So those are the things we need to check when we come to a valve to see if the zone is open or closed, see what kind of pressure we have after those valves, and make sure they're opening and closing properly. Okay, this is a red pipe. What this means, this is at the end of a submain. It's what we call a submain flush. So we're still on the feed end of the field. So behind to my west here is the submain that's feeding. We got all the drip lines going off here, and this is the end of the line. It's the end of the zone. And so there's a red pipe that comes up that basically allows us to flush that PVC manifold that all of those drip lines are connected to. So really the only purpose of this is to be able to clean that pipe out. I can take my pressure gauge, I've got a little Schrader valve, and I've got about 24 pounds of pressure here. If I want to get wet, I can put my finger in here and push this ball down in that air vent, and I can tell that I've got pressure there. So if I open this, I'm going to get a bunch of dirty water. So I'm going to go ahead and do that. They may have flushed already this spring. I don't know how dirty it'll be. This is a surface water system, so this is pretty dirty clay, gets a little bit of sludge. So it's not unusual for this to look pretty dirty. But just to get you an idea what this should look like. So if we let this run for 10 or 15 seconds, it's not going to take a long time to clean out. There's maybe feet of pipe to clean out between here and the top end. And with this 2-inch valve and all those drip lines, the velocity is pretty high in that pipe right now. So it won't take real long to get this cleaned out. Take a little sample, put it in your hand. You can see if there's any particles of any concern. At first there was a few particles, but now it's nice and clean. So everything looks good there. So that's the purpose of the submain flush. It's going to be a red pipe. All right, we're at a flush valve here. The reason we know it's a flush valve is because it's orange. The other way we can validate that is it's at the bottom of the hill. Most drip systems are designed to irrigate from top to bottom. So flush pipes usually are going to be on the lower elevation of the field. There's a few exceptions out there, but for the most part, they're going to be top to bottom. But orange pipe always indicates it's the flush valve. And basically there's going to be, on each zone, we're going to have 2 of these. So we got one here on the south side of this valve. We go about 400 feet to the north, there's going to be a second one. We only want to open one of those at a time. If we try opening 2 of them at a time, we're not going to get the correct velocity. We want the velocity in this drip line to get to 1 foot per second to know that we're actually scouring that drip line and cleaning it. So I'm going to go ahead and open this one up. And it should be somewhat clear here for a little bit, and then if it hasn't been done recently, we'll get a lot of dirt and some sludge that'll come out of this. Could turn super black. If you've got iron in your water, it's going to turn orange. So this is always an important maintenance thing to look at, is what color that water is. If you're concerned about it at all, let us know if it's something that's unexpected. But we're going to get some little particles, things that coagulate together once they're sitting in the drip line, and we'll be able to flush those out. So this is pretty common to see on a surface water system. You'll see little particles, those are specks, and then if I smear them with my finger, they dissolve again, they break back apart. So those are pieces that came through the filter. Once they got in the drip line, they flocculated together and are sticking together, and now we're getting that velocity in that drip line high enough to make sure we're flushing that out. During flushing operation, it's very important that the pressure is maintained high enough at the valve. So the way you know how many zones you can flush at one time is make sure we're maintaining pressure at the valve. If your system is designed for 25 pounds of pressure at the valve and you open up too many flush valves and your pressure drops to 20 or 15 pounds, there's too many open and the pump can't keep up. You're asking for too much water. So we need to make sure we keep our flushing velocities and pressures maintained properly so that we're getting a good scrubbing done on the inside of that drip line. So there's what's fairly normal. If you got a big chunk there, I can spread it out and it'll dissolve out again. So this is normal flushing conditions. So I want to let this run until that runs clean.